Hello, math peeps. Welcome to lesson 2, where we're going to dive into adding and subtracting radicals. Okay. Now, this actually isn't complicated if you are comfortable with lesson 1, which was simplifying. Okay. Because all we need to do is simplify the radicals before we can decide whether to add them or subtract them. Okay. Now, how do we decide whether to add them or subtract, or if we can add them or subtract them? That becomes a conversation around something that you would have dealt with in junior high called like terms, okay? And permit me, I guess you don't have to, you could just fast forward the next 30 seconds, but permit me to just remind you of the concept of like terms for a sec, okay? So if I had 6 apples and 3 apples, and I put all of those together in a pile, well, what would I have? I'd have 9 apples, right? 6 here, 3 here. Now they're all in the same pile, and I've got 9 of them. So those are like terms. I'm talking about apples and apples. So when I put them together, I just combine the apples. If I had 6 apples and 3 oranges, and I put those together though, what do I say? Well, I'd have to say, oh, I have 6 apples and 3 oranges. I can't say anything else because they're not the same type of fruit. And so they can't be combined together in one statement. That's really what like terms are all about, right? If I had 3x and 2y, I can't add those together because one's an x and one's a y. One's an apple and one's an orange. So when I put them in the same pile, I just say, oh, I have 3 x's and 3 y's. Okay. But if I had 3 x's and 5 x's, I could put those together and say altogether I have 8 x's. And it's going to work the same way with radicals, okay? So I'm going to just hide my face here for a sec so you can read the words. Adding and subtracting radicals follows similar rules to how we add and subtract polynomials. We can only add and subtract like radicals, okay? Radicals are considered like when they have the same root index and the same radicand. Okay, that's what makes them like terms. To add or subtract the like radicals, all we need to do is add or subtract the coefficients. The root index and the radicand will stay the same. Okay, so sometimes radicals don't look like radicals until they've been simplified. Let me just hide myself for 1 sec so you can see that. For example, let's check out 2 root 40 and root 90. Now, if I go to simplify 2 root 40, which again, that was the topic of yesterday's lesson. So if you need a refresher, go back there and just watch that again, okay? But I'm gonna look at this and say, okay, root 40 is root 4 times root 10. So root 4 is 2. So I end up with 2 times 2 root 10, which is 4 root 10. Okay, and then root 90 would be root 9 times root 10, and then the root of 9 is 3, so I'd end up with 3 root 10. And now I suddenly see the root index is the same, they're both 2, and the radicands are the same, they're both 10. And so this is like 4 apples and 3 apples, and if I put them together, I have 7 apples. So I've got 4 root 10s, and I've got 3 root 10s, and when I put them together, I have 7 root 10s. Okay, that's what we're doing there. Okay, and again, you could always check the question, check your answer. If the decimal approximation is the exact same, you know you probably did it right. Okay, so let's try a few together. First one, 8 root 3 plus 4 root 3 minus 5 root 3. Well, they are all like, so I've got like 8 apples plus 4 apples, then I ate 5 apples. I was hungry. So 8 plus 4 is 12, minus 5 would give me 7. So 7 root 3 altogether. Okay. Now, there is actually no mathematical need for the brackets that you see here because it says plus, right? If it said minus, that'd be a little bit of a different story because the negative would have to distribute to each of the terms in the bracket to the right. But for this guy, we're ready to just combine like terms. So I just want to put my ink on here for a sec. I've got negative 7 root 5. Remember that you always have to look at the sign in front of the number. That's important, okay? And 4 root 5. So together, that'll be negative 3 root 5. Then I have 4 root 2 and minus root 2. So that's going to be 3 root 2. Okay, so all together, I would have 3 root 2 minus 3 root 5. Now, if you had said negative 3 root 5 plus 3 root 2, that's the exact same thing. That doesn't matter, okay? All right. Root 3 plus root 5, can't do anything, okay? It's as simple as I can make it, and they're not like terms, so I can't simplify this any further, okay? Okay, now here's the example I was just talking about where if it was subtraction, just remember this negative kind of gets distributed to both of those guys. So this is going to be negative 2 root 3, but this is going to be plus 4 root 7. Okay, so negative 2 root 3 and positive 4 root 7. So then I've got 5 root 7 plus 4 root 7. That's going to give me 9 root 7. And then I've got negative 4 root 3 and minus 2 root 3 will give me negative 6 root 3. Okay, so that ends up being 9 root 7 minus 6 root 3. Okay, 9 root 7 minus 6 root 3. Okay, root 8 minus root 12 minus root 18 plus root 27. Now, on first glance, again, it looks like, oh, I can't do anything here. Well, you can't make that decision until you've simplified everything. So let's simplify root 8. Root 8 is root 4 times root 2, and the root of 4 is 2. So that would be 2 root 2. Root 12 is 4 times 3, or root 4 times root 3, and the root of 4 is 2. So that would be 2 root 3. Root 18 is root 9 times root 2, and the root of 9 is 3. And 27 would be root 9 times root 3, and the root of 9 is 3. So we would end up with 2 root 2 minus 2 root 3 minus 3 root 2 and plus 3 root 3. Now I can look for like terms. The 2 root 2 and the minus 3 root 2 will be negative root 2. And then the negative 2 root 3 and the 3 root 3 can combine together to be 1 root 3. Okay, and so that would give me negative root 2 plus root 3. Okay, negative root 2 plus root 3. So as I was saying a couple minutes ago, if you are solid on simplifying radicals, today really I'm hoping is not super stressful on you. Okay, the trick is to make sure you're solid on simplifying radicals. Okay, try this. You're going to want to simplify each one of these, and you're going to want to distribute that negative to both of those terms, okay? Just a gentle reminder, because I haven't said it yet this video, you should be pausing me each time, trying these questions yourself, and then turning me back on, okay? Okay, so root 48 would be root 16 times root 3, and then that would be 4 root 3. Root 180, off the top of my head, let's see. So 180 is 36 times 5. And now that wasn't off the top of my head. If you saw me look down, I was typing things in a calculator while I was talking to you. So 36 times 5, the root of 36 is 6, so that should be 6 root 5. Then my negative root 12 is going to be 4 times 3, so it'll be negative 2 root 3. And then that's going to be negative 6 root 45, but then the 45 is 9 times 5. The 9 will become a 3 and get multiplied by the 6, so that'll end up being 18. So 4 root 3 plus 6 root 5 minus 2 root 3 and minus 18 root 5 gets them all simplified. Okay, now 4 root 3 and negative 2 root 3 can combine together to be 2 root 3. And 6 root 5 minus 18 root 5 would be negative 12 root 5. Okay, so 2 root 3 minus 12 root 5. Okay, we can do this. Okay, let's summarize. You can only add or subtract radicals that have the same root index in the same radicand, okay? So if I had given you cubed root of 7 plus root 8, there's nothing you can do with that. You can simplify the root 8, but you can't put them together, okay? To add or subtract like radicals, we want to add or subtract the coefficients, and then we keep the root index and the radicands the same. Okay. It never hurts to write out all your perfect squares or cubes before doing this question. And I talked about that in the last lesson. Just to do, even on, especially on a test, just build those lists at the top of your test so that you've got them and you're not stressed about them. Okay. And you can just go 2 squared, 3 squared, 4 squared, and so on. Okay. All right. So if you're my kid at school, this is your homework that goes with your workbook. Make sure you're giving yourself some time to go through it and to ask me any questions. Please make sure you're asking questions. I know I probably end every video saying that. It's really important to me, okay? I want you guys to feel good about this stuff. I want you guys to understand what you're doing, and that's what I'm here for. So please make sure you're connecting with me with any questions that you have, okay? You guys can do this. I will see you for the next lesson where we're going to tackle multiplying radicals together. Okay, see you then.